Hello, folks. Welcome to another live streaming session for the Context Bonsai plugin. The last several days, we've continued our work on the Context Bonsai plugin, particularly in creating an automated rebase system so that when a new version of OpenCode comes out, we can automatically just take an LLM and apply the necessary patches to the latest version of OpenCode without running into any issues. And this is part of a larger process of getting this thing ready for release and making sure it's maintainable ongoing and making sure that the changes inside of OpenCode itself are as minimal as possible and as much as pushed out into a plugin as we can. And that's the primary area we're working on. And on the side, we're running not small sub projects. We're running several side projects where in those side projects, we are actively using our Context Bonsai plugin to make sure that the plugin works the way we want it to. So what I started doing this morning, first of all, I'm playing with Claude. Let's see. Oh, maybe not. Is this... Make sure I'm on the Claude side. This is actually OpenCode, isn't it? Nope, it's Claude. Okay, yeah. So I'm playing around in Claude, and the reason I'm playing around in Claude is because there's a new model that was just released. Claude Opus 4.7 is out, so I started playing around with it. And the task that I've given it is to dig into OpenCode and understand how OpenCode uses prompt caching, dig into Context Bonsai and understand how Context Bonsai works, and then go do some research on the pricing and find out the cost of regular API usage and cached API usage. So it did its research, it figured out how everything works, and wrote a document about it. And then I asked it to go grab the session where we've been running our longest project so far, the image to maze project, where it's been going for quite a while. Ooh, Claude Code just did an auto compaction. Interesting. Yeah, I'm finding out that when I don't have Context Bonsai available, I hit those context limits so fast, and it gets to the auto compaction so fast. It's quite a surprise after having been using Context Bonsai for so long. So where was I? Right. So then I had this go look at the session where we've done the image to maze project. There have been 765 turns in that session, and I had it build up a price model for how much did this cost while using the plugin, and how much would it have cost had we not used the plugin. And after the first 141 turns, it would have already hit a max of 400k context. That's actually already well past when auto compaction would have hit anyway. But that's where it limited like one of the estimations, and that would have cost $4.91 with using Context Bonsai. It would have cost $6.41 without using Context Bonsai. And that is on the early part where Context Bonsai didn't have all of the tuning we had to make it more aggressive in its pruning messages away. So that already is pretty cool, 23.5% savings. These numbers feel very low to me. I don't completely trust them. I think I'm used to like a full session when you do enough work that you end up triggering auto compaction. I think that typically costs on the range of like $40 or $50. So I'll have to look more carefully at that. And then it also produced an estimate as if you had infinite context window, and that entire context window was the same price as the small context window. If you used that calculation for the entire session, then it would have cost $43 with Context Bonsai plugin and $165 without Context Bonsai plugin, 74% savings. That's pretty dang cool. That came up because there have been several times when I've mentioned this plugin to people and they instinctively say, that won't help because you're running prompt caching. And I intuitively thought that was obviously wrong for Even the base mechanical way of how prompt caching works, I don't think that that works out. And even separate from that, you're not counting all of the benefits of having a long running session, of being able to clear out things out of the session that are destroying the session, and all kinds of stuff. So it was pretty cool to see this simulation. That's what I have been working on so far this morning. Let's see what else. Um, I don't have my previous prompt. It's not showing it there, unfortunately. Is it here? Oh, yeah. So, in its own analysis of how OpenCode does prompt caching and how our gauge marker works, so in Context Bonsai, the gauge marker is a message that's inserted every 5 messages that tells the model how much um, of the context window has been utilized so far. It says something like your context window is currently 100,000 tokens or 50% used. Consider using Context Bonsai to prune away old messages that are no longer needed. So that message is ephemeral and it only lasts one API call. It makes the API call, and then the model may or may not decide to go ahead and use Context Bonsai. And if it does not use Context Bonsai, it just continues like normal. If it does use Context Bonsai, it'll do a tool call, and then after the tool call, then it will continue its normal response. But either way, then the next time, for the rest of the conversation that happens, that reminder message is gone. It's not included in the message, which means that if that um, if the reminder message was added to the cache, then the next message after the next API call after that, which doesn't include that message, wouldn't match anything that had been previously cached. So that cache entry is completely unutilized and would never be used, which is a little bit of a problem because inserting things into the cache costs more than a regular API call. Using things that are in the cache costs less. So the idea is you should be able to insert things into the cache and then use that insertion multiple times and get a little bit of benefit every time, and it overall costs less than the extra insertion cost. But if we're inserting the reminder and then never using that cache entry again, that's a bit of a problem. So I asked it to take a second look at that and make sure that what it said happens before is actually what happens. So it says, let's see, it outlines the flow. I already know the flow. Caching. It does put cache control on the last 2 non-system messages, so your last couple aren't attached. Intuition is wrong. So what I thought happened in OpenCode was the most recent couple of messages aren't actually cached, but like as those messages get older and new messages are added, those messages would end up being in a cache entry. But what I thought about that was incorrect. So that's interesting. On a gauge turn, the last user cache entry is written with the gauge text inside of it, and the next turn request has a different content. So that entry is stranded. Interesting. So we might have some modifications that we want to make. It kind of depends because that would probably require modifying OpenCode itself. I don't think that's something that's going to be exposed in a way that plugins can access it. And I'm trying to minimize the amount that we're changing to OpenCode. And since overall using Context Bonsai is already a benefit, the fact that it wastes a cache entry is not the worst thing in the world. We kind of overcome that by the ability to use the tool at all. Okay, tangram session caveat. The session we're analyzing is a different model, sure. Apply caching is only invoked for Anthropic family providers. Oh. So OpenCode doesn't use prompt caching with other providers. Interesting. Oh, OpenAI does automatic prefix caching. Okay, well, we don't have control over that, but the same issue applies, is that having a cache miss is for 1 out of 5 messages, you will have a cache miss, then that's okay because of overall it still saves money. Okay, now I'm a little calculation. In my experience, a full context window enough to trigger auto compaction is around let's say $40 to $60. But you say it's an order of magnitude less. What are the factors that went into your calculation? Did you make sure to calculate costs for every turn of the conversation? And the way I've built this intuition is by, when we're using OpenCode, oh, this does not show a cost usage. Okay, let's go like this. The other thing, actually, I don't know quite how to do this correctly. I do have API keys for other services, but those API keys themselves are a subscription. And I don't know how OpenCode tracks that cost. I don't know if it accurately knows how much that subscription is, or if it just has like the cost of this model is this much, no matter who the inference provider is, that model is this much. I don't quite know how it works. That would be something interesting to learn, actually. Let's go back to this. Okay, that's still busy verifying. Let's move back to our Context Bonsai project. So I did do some work on this thing off stream yesterday. I don't quite remember everything I did. Probably is over here. Commit safeguards. I don't remember. I also did a bunch of work yesterday, and I don't remember what landed on the live stream and what I poked forward afterwards. But one of the things I intended to work on was adding safeguards so that if oh, this is not even Context Bonsai. This is the LLM conductor project. Okay, so we worked on 3 projects yesterday. LLM conductor, my orchestration system that tells the model how to produce multi-step plans and then how to orchestrate those plans and get the entire thing done. And one of the things when running these plans, I found out that the models were leaving behind changes that were uncommitted for some reason. It's a new behavior that didn't used to exist. Whoops. We used to pretty reliably be able to work through a whole project and have a clean working tree with nice, well-formed commits. So I went back to the orchestration system and added some commit safeguards. That before it starts work, it checks out what uncommitted changes there are, and if there's anything that looks like it's going to be modified by the current task, it stops and says, hold on, these files are uncommitted, but I'm probably going to modify them. So before we start, take a look at this. So it does that. It also makes sure that the plan itself is committed. And the planning guidance should include a step to commit the plan. Okay, I wonder how much of that is included. So it looks like the most recent thing we did, require committed plan for orchestration, is done. 0 issues found, approved as is. That one was completed. Let's see. I wonder what happened before that. Here's where it's iterating on the plan. Okay. Here we go. The previous thing that completed was orchestrator scope clarifications. That was where we told the orchestrator, we clarified to the orchestrator what kinds of files it's allowed to modify versus what it's not allowed to modify. The agent that's doing the orchestration and planning is allowed to mess with the planning documents. It's not allowed to make it actual changes. And the reason I did this was because there's been several times where I'm working with the agent and I said, okay, next I think we need to make this kind of change. And rather than talk to me about, okay, what does that mean? Let's get some clarification on the details. Let's talk about this before I start things. It just goes and jumps in and messes with the code. Even though there are multiple pieces of context all over the place where I say, don't do that, it still has been doing that. So now I have put it into the orchestrator instruction directly. So if I ever tell an agent that it's an orchestrator, it will read the orchestrator instructions and see that it's not supposed to modify the files. It's allowed to mess with the plans, but it's not allowed to mess with the actual code in the project. So that was this project. Let's see, and before that, this plan, okay, still messing with the plan. Oh, go away. That's where I'm still working on this. Actually, let me just ask it. I have a to-do list and I don't remember which things we did. Tell me which ones are already done. Do not attempt to do them. All right, let's copy all of these. Oh, I already moved some to old. Let's make this bigger so I can copy it better. Okay, we'll let that think a little bit. Now let's jump to the Context Bonsai project. Okay, so this is the OpenCode rebasing automation system. So the way this works is I have a meta plan, and the meta plan can be combined with the orchestration. You tell it to orchestrate the meta plan to produce a concrete plan, and then you can tell the orchestration system to orchestrate the concrete plan. So the meta plan is sort of this general guide on how to do a rebasing project to get my Context Bonsai commits rebased onto the latest version of OpenCode. And what I did yesterday is I sent it around on a loop, and the loop is way too far old. Okay, well, the loop was something like resets the working tree back to our baseline, update the meta plan with the things you learned when you tried the previous time. Then once you have a verified plan, orchestrate the plan to try and produce a concrete plan. Then orchestrate the concrete plan to actually try to do the rebase work. And if it didn't work out, if you ran into any issues, learn from that and go back to modifying the meta plan again and do the whole process all over again. So then it would reset the code base and redrive all of the things. So I'd set that off in a loop, and it says, well, I don't trust its output here because there are now two loops. There's the building the meta plan loop, and then actually there's more than two loops. There's two layers of loops, I guess. There's building the metadata plan, which will do its own little loop cycle. And then there's doing the concrete plan, and that's its own loop cycle. And then there's orchestrating the concrete plan, and that's its own loop cycle. And then it has to take care of going back and doing the big meta loop over again. And this looks like it stopped at the end of one of its planning loops rather than an orchestration loop. And stopping at the end of the planning loop, like if it stopped at the end of a meta loop, that would be one thing. If it stopped at the end of one of the like the concrete implementation loop, that would be slightly suspect. But this is stopping at the end of a plan, so unfortunately, this is not good enough. Oh, I guess all I did the most recent time is to build the plan. Your job is to continue the meta loop. You keep stopping without actually doing the meta loop. Describe to me what you think I mean by the meta loop. Let's see. The full closed cycle, not just writing a plan. Update the meta plan, generate a concrete plan, orchestrate execution of the concrete plan, collect defects. Yeah. Keep doing that. Do you remember the finish condition? The loop is practically smooth end to end. Yes. Okay, so keep doing that. Please don't stop unless you run into something that you don't understand how to fix. Let's see if it can do that. If it stops again, I might go over to Claude and the new model and see if it can handle it. That would be a fun little test. It's doing a context bonsai prune. Okay. And that is a very old conversation. So one of the changes we've made to Context Bonsai is we gave it a little bit more guidance in the tool instructions about which parts of the conversation to choose to prune. Particularly the oldest and the largest have the highest priority, and we also gave it a little bit of warning that some of the earliest messages frequently contain like your operating instructions, like don't do this kind of behavior, do that kind of behavior. Make sure you write code according to this coding style, whatever, those kinds of things. And the tool also has those sorts of warnings of you don't want to erase messages that have operating guidelines, overall operating guidelines, but you do want to eliminate messages that are old and very completely completed and don't affect our future work. So this is good. That is a pretty old message that is completely irrelevant now to the work we're currently doing. So it made a good choice there, and I'm glad for that. Now, I think in this one, we might have, in one of the sessions from yesterday, yes, it was this one. In one of the sessions yesterday, it made a very poor pruning choice. It may be this message. It was something that happened, and it was a relatively recent message, and it was only one message, and the context was very close to its limits. It was like in the mid or high 60s, which is right around the time when OpenCode decides to do its auto compaction. So it did one message, and it was a recent message that was somewhat useful to what we were doing, when there have been tons of old messages that should have been much higher priority. And this was already after we had updated the tool guidelines to tell it how to choose better messages. And I'm hoping that the issue with its choice was that the context window was already very large. And when the context window is very large, the model generally does behave very poorly. And I'm hoping that that was just because the context window was so large there. And after a little bit, I said, you need to get context down significantly by about 60,000 tokens. And then it got rid of a whole bunch of stuff. And I think I was also dissatisfied with some of the stuff it got rid of. Let me see. That one is fine. Oh yeah, that one is fine. That one's probably fine too. Maybe they were okay. Maybe they were okay. I thought I remembered seeing stuff that I wished it hadn't done. Hmm. Anyway, it did like, I don't know, a dozen of these context bonsai prunes to get the conversation down much further. I'm not sure quite how far down I got. Let's see, we've had how many messages now? Oh, we've done quite a bit, and we're currently at 48%. So it probably did a pretty good job of getting the context down there. Okay, so this is on its loop, and now I'm hoping this is able to continue its meta loop. So far, it's only ever made it through one. It's never restarted the meta loop over again. And if it fails to do it again, I think it's time to go try the Claude model. Okay, so that's where the Context Bonsai stuff is. I think I may have added a to-do list for the plugin side. So on Context Bonsai, we've got two different code bases, the plugin and OpenCode itself. And the plugin, I thought we were more or less done, but we did make some changes yesterday to improve the guidance. Oh, that was the to-do that I had. So I guess that is all done. So let me take this and put it down here under old and mark it as done. Nothing at the moment. Okay. So there we go, window 1, window 2. Now let's go on to our image to maze project. Before I do this, I need to launch a browser so that we have the GUI. One of the things we're working on is a GUI for this tool. But overall, this tool will take an image and it will produce a maze. And ideally, what we're going for is getting the maze to look like the image. And I'll show you in the GUI what we were able to get to yesterday. But first, let's... Oopsie. There we go. Okay, got my browser, and I need the... There we go. Okay, so now we can go grab an image like this. First of all, one of the things that we can do is change the brightness and the contrast of the underlay image so that we can see the maze clearer. So let's turn up the brightness, turn down the contrast a little bit nicer, turn down the contrast further, turn up the brightness further. There we go. Now the maze is mostly present and we can kind of see the dog underneath. And so to start, we need to invert which parts of the image has the maze drawn on it, because right now it's avoiding the light areas and it's putting more maze on the dark areas. So we want to invert it for this particular image. Okay, now it has a little bit more on the dark area, light area, and less on the dark area. Now we want to make it more dense. So I'm going to increase the grid size quite a bit. A little more. A little more. Okay, now I'm going to bump down the minimum radius, which is kind of how curly the maze is. Okay, now the most curliest parts are on this bright white tongue. And I also want to adjust the thresholds so that when it gets down below a certain darkness, it doesn't draw any part of the maze. That should be the threshold. No, the floor. That will be the floor. There we go. Okay, so the very darkest part has no part of the maze. the most dense parts of the maze are light areas, and then the other densities are, they kind of depend on how light it is. So here on the snout, there's a light area, and that has a little bit more dense, more squiggly parts of the maze, and then the shadier parts are less dense. Let me do also reduce the radius max. So overall, there's just going to be more density in the maze. And here's one of the things that happens. Okay, so I'm messing with these values little by little, and there are, the way this maze is modeled, there are discontinuities where certain combinations of values will cause nothing to be rendered at all, or it'll cause like only parts of the maze to be rendered. So as we're messing with this, it will go through times like this, where now there's a little bit of maze on the tongue there, but none anywhere else. But if we keep going, we might find a spot, there we go, where it does have some stuff. And now it's looking a little better. Quite a bit more density here on the snout. I do really like that the most shady part of this, or the large shady part here on the sort of shadow side of the dog's face, has very little activity. And the more grayish parts, like the actual parts where light is reflecting off the dog better, we do have sort of this general squiggliness. And it is sort of in the shape of the dog. If we turn off the image part of it and we just look at the maze, we can see the outline of a dog. If I knew it was a dog, but I didn't know more about the image, I would think that this part's the nose and these are the ears, and maybe up here is where the bridge of the snout is, and the eyes aren't really showing up very well. That's what I would guess, but I would be wrong. This is actually tongue. There's a nose here. This is like the front light part of the snout. So there's more tuning that we have to do. And what we did yesterday is add this curves feature where we can remap the input tones of the image to a different set of values that are used for generating the map. So we can take like the midpoint and make the midpoint of the image like lower. This image is overall dark. The sort of medium gray part of the image, let me turn the image back on and turn it all the way back up. Oops. What can I type here? There it goes. 1, 1. Okay. So like the medium, conceptually medium part of the image would be sort of the fur on the dog on places that aren't super highlighted or super shadowed, like this part of the ear. That should be sort of the middle value of the full range of map values, but it's not the actual middle value of the total brightest and total darkness possible in the image. It's actually pushed all the way to the dark side. So this is reading as less dense than it should. So what we want to be able to do is bring the value of what we consider, what we perceptually see as the middle of the image. We want to bring that up so that it's actually mapped to the middle of the value range. That's what curves will let us do. So here, well, actually what we want to do is take the dark parts. Oh yeah, another thing we did that's cool is you can hover over the image and it shows you where on this curve it is. It shows you actually both what the output value is and what the input value is. And right now the curve is completely smooth. I mean, it's completely one-to-one mapping. So they're the same input value to output value. So if I wanted to make the darker parts of the image show up as a higher value, a more dense area for the map, then I would take this general area and like I'm hovering over the ear now, and we can see the ear now is this lower bottom left quadrant. So if I take these values and I bring them up, that should add density into the ear. We're going to have to turn off the image or reduce the contrast to be able to see this. So let's put that back on 0.2. Push this upwards again. Okay, now we can see the map a little bit easier, or the maze a little bit easier. So if I bump this up, we should see density increase here and in the rest of the areas that are also sort of that color. Okay, and now because we've raised some of the lowest values, those lowest values are creeping up past the floor. So now I'm going to push the floor up to get rid of this most outside part. There we go, now we're back. Okay, so now the mediumest parts are more dense. The midtones probably should also come up. And for that matter, the highlights can too, because there is not much detail within the highlights areas. So I think doing this makes the brightest values less differentiable. There's a large amount of bright values maps to a small amount of output values. And because there's way less detail in the bright values, it's fine. We don't need a whole lot of ability to discern what's happening in those bright areas. We do need a lot of ability to discern what's happening in these darker areas. So I think that is generally closer to the shape we want. And now I've landed on a specific set of values that can't draw anything. So let's see, what have I done? Bring it down, bring it down. We might want to dig further into the non-linearities of this calculation to make it so that this happens less frequently. Or make something that finds the closest values that have some amount of maze on it. I'm not quite sure how to specifically do that because every image is going to be very different. Any values for one image is going to be different for values for another image. But okay, now we have something pretty cool because it's high density on the brightest areas, like where the tongue is. There's also this ring of light-skinned fur around the eyes. Let me bring the image back a little bit. Yeah, there's this light ring of light-colored fur around the eye, and we do have higher density there. That's pretty cool. We also have this light area on the snout, and we can see more dense stuff happening there. That's pretty cool. But overall, we still sort of, if I turn off the image, it's kind of dog-ish. Sorry. It is cool. We're way further than we started when we started messing with the grayscale images. And we may be as far as we can get with this particular method. So I started exploring another method. I had another idea for something we could do. I actually had, I created two plans yesterday. One of them is, here's my prompt. One of the plans was about a different method, and one of the plans was about an improvement on the UI. The improvement on the UI I wanted was that the inability to move these markers left and right is a bit of a problem. All I can do is adjust this like high, medium, low point, and they're fixed. So I can't do fine-grained adjustments. If there's one particular part of the image that is really important to have more detail, and if that part was specifically right here, I can't adjust just that part without also pushing up the things around it. So I wanted, first of all, to be able to scoot these left and right, but also to be able to add additional points wherever I need, just like you can in Photoshop. You can add as many points as you want in here and move these around willy-nilly, and it sort of fits a Bezier curve along the points, I think is how it works. But anyway, this is how I explained it to the model. I said, I'd like another plan created that we're going to orchestrate before that one that other one, though, that one I'm referring to is the other method of generating the maze. The curves UI, it needs some adjustments. I want to be able to, one, add or remove as many nodes as I want. And two, the GUI should add remove the spinners as nodes are added and removed. And three, the curve should be smooth, but the GUI is showing straight lines between the nodes. What does Photoshop do to fit the curve? Let's copy that, not just for the GUI, but also for the actual mapped values. I think it uses a Bezier curve because I think I remember being able to modify handles. Okay. And, oh, for some reason I have another three. The endpoints should also be movable, not just the interior nodes. So yeah, so right now I can move these three nodes, but I can't move the right or the left. So it has generated a plan for us, but I've not looked to see what it did. So it will add or remove arbitrary nodes. Endpoints are movable in both X and Y. Oh, I wonder what moving endpoints in the X direction does even. Huh. Let me ask it about that. Click drag node editing, dynamic spinner rows that add or remove with the nodes, good. Two-way sync, graph edits update spinners and the spinner updates update the graph, cool. Smooth cubic Bezier curve used for both UI rendering and actual remap values, good. And deterministic contracts for handle, behavior, and evaluation, okay. Okay. I'm relatively satisfied by that, but I have a question about the endpoints movable in both X and Y. What does it mean for the input to be movable on the X-axis? That's the input values. It seems like we'd have some values that have some input values that have no mapped output. Okay, let's let that think for a little bit. See if our Context Bonsai thing is working. This one. Okay, Context Bonsai is still doing the meta plan stuff. What else did we have? Oh, the token calculation cost. So I had a question. I said I'm suspect of its cost calculation, and I asked it to make sure that it's calculating correctly. Let's see. Your intuition is right. For Opus, this session is Codex, which is 3 times cheaper at every tier. Here's the breakdown. Every turn is counted. 765 assistant turns, 765 CSV rows. Sum of per turn is cost underscore A equals blah, matches cumulative, no gaps, no resets. Okay, interesting. Arithmetic cross-check directly from recorded usage. Input, cache read, output. Okay, it looks like it's doing it correctly. Oh, you know what? I wonder if OpenCode's own cost calculator doesn't calculate cache reads. That would make a huge difference. That could be the whole issue. Because imagine we're spending $23 on uncached input. Oh, no, that uncached input doesn't matter. Uncached output would, but the output is so small compared to the input. I am also highly suspect of that little tiny output. There's no way that's correct. 220 tokens across the entire session. Right? The $43 was the full session. Yeah, because the smaller one was under 10. Why it's so much less than your $40 to $60 instinct. The model, I don't care. Cache hit rate is 88%. Okay. codex cached input is 10x cheaper than fresh. Yeah. And the output is tiny. Yeah, that's funny. That my own like things, the things that I notice when I'm looking at this are the things that it pointed out here. The model isn't a whole order of magnitude difference. That's it's these things that are suspect. 228 tokens per turn average, or 288 tokens. That sounds more like just its own conversational output, but not like its code out, its tool calling output. Um, hmm. Interesting. I'm gonna have it double check that part, the output part. Peak context, a never hit auto compact. Max content A is that many tokens versus that limit, which is about that much auto compact threshold. 0 turns above 300,000. What? Let me see if I can understand what A means. Last turn B. I don't know what this means. It's referencing things that are in some spreadsheet that I haven't looked at. That's exactly the plugin doing its job. 36 prunes kept things well under the ceiling. In scenario B, the peak would have been that many tokens, infeasible without compaction of some kind. Sure. One small accounting miss I found, reasoning tokens are stored in a separate tokens.reasoning field, not folded into output. Oh. Are the token calculations recorded in the session file per turn? Yes, per assistant message, which is one-to-one with API turns here. Oh, okay. Well, maybe it did do the right thing. Can you do a quick check to see if that includes tool call output, such as writing files? Tool call outputs are absolutely counted, but they show up on the next turn's input. That's... I am suspect of this. Like, it makes sense for the conversational output to be part of the input of the next turn, because the model has to see the whole conversation. It has to see, like, every message that's happened back and forth. So if the model says something, then the next time the user says something, it includes the full conversation, including what was just said, so that would naturally be included. But tool calls? I don't know. Turn 113 is the cleanest case. Context jumped plus 109,000 tokens, and fresh input on that turn was also 109,000 tokens. The bash output landed straight onto input tokens. Okay, uncached. The bash result is billed in the token count. Ah, that's not what I mean. No, that's not what I mean. I think you're talking about something like a tool call was executed, maybe bun run test, and that generated a bunch of tool call output, which is then part of the next turn as input. That's not what I'm talking about. I'm talking about, for instance, when I asked you to write some file, where's the file that it actually created? This. Nope. Oh, actually, let's just do this. There, copy to a file, example below. Yes. The tokens the model generates as tool call arguments is what I want. That's a way better way to describe that. Okay, it says tool call arguments the model generates are counted in tokens.output. Okay, well, that's surprising. Just the huge difference between how many read combination of input tokens and cache reads. Those are all sort of input into the model. Okay. I guess to an extent it makes sense because you can like call a write call and generate a huge file. Then the next turn doesn't have all of that output unless it reads it again. No, it would have it. Interesting. What I was thinking is maybe output isn't part of the accumulated message, but it is. If it writes to a file, then that tool call, the list of tool call arguments is in the ongoing conversation, I believe. Is our tool call arguments part of the ongoing conversation? Like, if I asked you to write a file, then you wrote it and said you did that, then I sent another message about what you wrote. Would you, the LLM, see the original write tool call arguments and know what you wrote? Finish this parenthesis. There we go. Yes, tool call arguments are first-class conversation content. They're replayed on every subsequent turn. Okay, that seems pretty surprising. But I think that's enough conversation to be more or less... I mean, I'm more confident in those numbers than I originally was. It just seems really cheap. But that is pretty cool. 74% savings. Not just 74% savings due to raw token usage, but also like it didn't hit auto compaction, which means it didn't have to do a reread, like perform a bunch of tool calls to reread stuff and get all of the stuff back into context. I guess that's probably fine because when it does auto compaction, oh, I think for the full session, we have to model that as if auto compaction happened every, I don't know, 200,000 tokens or something. Let's add another mode instead of an everlasting context. Instead of an well, let's add a third calculation mode. We have the we have one until the first forced compaction, two, pretending compaction never happens, but context window is unlimited, and three, well, now I want to add three. Compaction happens, and it costs, let's see, some amount. You currently have an active context where compaction did happen. One of the very earliest messages, or maybe even system prompt, contains a compaction summary. Use that to estimate the compaction cost, but double it because the model will probably have to. Actually, it's more than double. It's probably going to be like 5x it. To spend several tool calls rereading files into context. Okay. I actually probably should have added a little bit more. The first one would be non-cached, but then the next 5 times it sees the same compaction summary, that would all be cached reads. And I'm also going to get it to do the same calculations, but pretend that was using Claude 4.7. Okay, that's going to spin a little bit. Let's go take another look at the Context Bonsai guy. Still doing the meta plan thing. Great. Oh, it looks like it's keeping a whole separate document for tracking the meta plan itself, or is this still just iterating on the meta plan? Oh, it's iterating on the meta plan. Okay, yep, still working on it. Okay, here. Oh yeah, I had the question about what it means to allow the endpoints to be movable on the x-axis. Great question. You're exactly right to flag that if endpoint X is movable, then yes, parts of the input can fall outside of the node domain. That's why the plan locked this behavior. Oh, okay, the plan locked it for X is less than or equal to first node.x, output equals first node.y, left clamp. What? For X is greater than, oh, it just clamps it. I get it. Whatever value that is, it clamps it. So anything, if the endpoint was moved this way, then anything to the left up until that would all be at 0. All right. Yeah. That's fine. That makes sense. Oh, Photoshop keeps the endpoints at 0 and 1. Sure. Let's leave the endpoints stuck like Photoshop. Because if the endpoints are stuck, but we have we can add and remove as many nodes as we want. We can just add a node. Like we can basically like put a node on there and push it all the way down like this, and it has essentially the same effect. So yeah, endpoints being stuck is fine. Okay, redoing the plan. I'm probably going to ask it to, ooh, it's doing some pruning. Is that recent? Oh, that was after I asked it this. Okay. So I'm paying extra attention to all of the pruning calls that it does because the whole point of this activity is to make sure that the LLM is using this plugin in a way that's beneficial. Oh yeah, this is very old content that is no longer needed. Good choice. This one, also pretty old, unneeded anymore. It made good choices that time. I'm happy with that. All right, it's updating the plan. I'm hoping it's going to go back through the reevaluation loop because the planning guidance document, okay, it's not done. So the planning guidance document says when you create a plan, then you also run subagents to do some validations. Need to treat this as an iteration and get your subagent validators to run again. I probably should have been a little bit clearer because it just offered to orchestrate, and the orchestration thing also has like an iteration loop. But it understands this is a plan iteration and it should rerun the validators, and it's doing it correctly. Good. Okay, that's doing the work I want it to do. The Context Bonsai agent, still doing the meta plan stuff. The cost calculation thing finished its scenario 3, scenario C, $51. Okay, that's interesting. So if auto compaction was routinely happening, then it would have cost $51. So that's a much smaller savings. That's interesting. Okay. Yep. Okay, so we're back at some way more modest value. Whatever 43 divided by 51 is. Does it tell me? Nope. Oh, yeah, it does. Okay, 15%. Not bad. All right, so I think the until first turn, the estimate was 25% savings. Oh man, that's so far up here now. Here we go. Here, that's not the table I want. Here we go. This is gonna have it. Yeah, 24% for going up until the first turn. Interesting. That's a little surprising because I'm pretty sure the first turn had the least effective context bonsai usage, and it only got better as it went forward, but it's saying no, essentially. It's saying it sort of reduced inefficiency down to 15%. Huh. Okay. Okay, well, that's cool. Glad I got that simulation done. Happy to see that the tool is not increasing costs by messing up the cache prompting. Now, when someone says that, I can say I ran some simulations and we got 15 to 25% savings. Completely aside from the other benefits of having Context Bonsai. Okay, so it finished the plan, it seems. And yeah, the validators found no issues. That's kind of what I expected, but sometimes I'm surprised. So now orchestrate it. Maybe I should have gone into the other method that I was talking about before this, because now this is going to take a while. And we may not get to talk about the other method. Actually, while this is going, I'll talk about the other method. Let me do a search for context-aware scaling. So my idea was context-aware scaling. Let's see if I can find a video demo. Okay. Oh, geez, there's an advertisement. I forgot that I'm not signed on to YouTube in here. Skip. And another ad. Okay. Oh, I forgot that the audio is going to be piped through. I kind of wanted to fast forward. Let's just mute this guy for a little bit. Where is the mute button? Pause. Oh, there we go. Okay. All right. So, he's going to resize this image, and it's going to kind of look like magic. It's not just going to make everything look narrower and squished. It's going to magically sort of get rid of low value pixels. Let's see if we can scrub this and see the magic happen. Whoa, what is he doing here? Did he already do it and move on? Oh, yeah, he did. Okay. So I think he is squishing the image down vertically here. Yeah. And it's going to kind of be like magic. It's just going to shorten the trunk of the tree. It's compressing the leaves up here a bit, but it didn't like cause the whole image to be squished. That's pretty cool. So that is context-aware scaling. And the way it works is it finds low energy paths from one edge to the other edge of the image. So it probably found a path that was something like this, from here down through here, down across the middle of the trunk, and then up through this blue area over to here. And so when he shrinks it down, this blue area has pixels removed out of it. The trunk has pixels removed out of the middle here, this sky area here, and then sky area here. The sky area pixels are low value. There's not much detail there. So messing around with those is going to cause less sort of semantic change to the image than messing around with other parts. So yeah, it's able to sort of scale the low energy parts and leave the high energy parts, the parts with the most detail, alone. So that's the idea that I gave to the LLM. I wonder if we can find the plan. Let's go here. Oh, there's another OpenCode session there. Okay. Okay. Here we go. Seam guided Poisson sampling. Let's launch an OpenCode, or let's play with Claude a bit. So here's Opus 4.7. Read that. Oh, actually, it kind of needs to understand the project as a whole, doesn't it? Okay, actually, no, that's a decent summary. It's a plan to add seam-guided Poisson sampling to the maze generator, detecting low-energy seams via Sobel gradient and seam carving, then biasing. Oh yeah, so the idea is it's going to find seams in the image, and along those, once it has the seams, when it's generating the points, the points on the image that turn into like nodes, the branches um, that sort of, I guess you have to be familiar with graph uh, language to understand, but where two legs, or really more than two legs, I guess, uh, but where multiple legs come together, this is a node. Actually, in this case, this is also a node. So yeah, this is a node, and this is a node, and this is a node. These nodes are placed randomly, and then um, it's using some heuristics to draw the edges between all of the nodes to generate our maze. So the new idea that I'm adding is when you're placing the nodes, don't just place randomly, bias them towards the seams of the image. And I'm hoping that identifying seams on the image is going to help the nodes sort of line up and outline areas on the image that help us identify sort of the more semantic context about what's inside of the image. And it may be that I don't want to bias towards the seams. I may need to bias away from the seams, or we may have to do something because the seams are actually the low energy areas, or the areas with little detail. So putting more points where there's little detail might be the opposite of what we actually want. But I'm gonna first try what I have now, but I expect it to kind of be not quite what we want, but will be informative and will help us think about how we can use these tools to get a maze that helps us understand what it's trying to represent a little bit better. It'll help trigger like the pattern matching synapses in our brain to help us understand what it's supposed to represent. Because as we saw, that dog isn't really understandable as a dog, but if we know it's a dog, we can kind of match up and understand why it generated it that way. But just looking at the maze, it doesn't really stand out as a dog if you don't know what it is. So I'll be experimenting with that next on the image to maze generator after it fixes the curves UI. It might be about time to end this session. Ooh. Oh, hey. The Context Bonsai meta loop thing came to a pause. Let's see what happened. I kept the meta loop running end to end, not just planning. What I just did, integrate some story into the metadata plan, regenerated a concrete plan, executed the new concrete plan. Ooh, it did. It did a full meta loop and it went back to the meta plan. That's cool. And then ran the full metadata plan validation loop after each change. Oh, nope, it didn't do it. It didn't do it. It says it's going to. I understand the loop and I'm continuing it. And then it just stopped. That's funny. You claimed to be continuing the loop. Yet, you're stopped. What happened? Maybe I'll give it one more try. Because that was the closest it's gone so far. It at least understands what it's supposed to do next. It just didn't actually do it. Okay, we'll see what happens. So yeah, I think we're done on the cost calculation. The meta plan thing is going to keep iterating for a while. Oops, that was a whole different story. What was this? Oh, the LLM orchestrator. Did I finish that? Yeah, that's all complete. Yeah. Oh, actually, I did ask it to tell me about the to-do lists, didn't I? Yeah. Okay. So it did those two things, but something likely covered, but wording dependent. Oh yeah, okay, fine. It covered it. So everything in this to-do list is done. Let's take these, put them down here, and done. Uh, okay, cool. Oh, there's no project name here. This is LLM Conductor project. Okay, so yeah, LLM Conductor's done for now. And both of these other projects are doing stuff, and the stream's been going for over an hour. It's a good time to go ahead and end it, I think. Thanks for joining me. We'll continue, maybe not exactly where I left off. I'll probably poke these forward in the background as I work on other projects today. Thanks for joining me. We'll continue tomorrow.